Okay, hello everyone. Welcome to the analysis meeting on February 1st, 2022. Also, happy birthday to Nikolai. Shout out to him. Hopefully he's watching the recording. On the agenda for today, we'll have our usual check-in and then just some reminders about the COVID protocol and the testing that will let us be in the lab. And then an overview of our task agreement. And then kind of continuing from last week, just because these are the major projects and major responsibilities we have at the moment. Talking about the fin shape decision, what we did in the lab yesterday, what we plan to do in the lab tomorrow, and also a finding of divergence velocity. And then just some standard updates on the Boattail FEA, and then assigning you guys some documentation updates to complete before we start our work on the February progress report, and then we'll end it off with questions as usual. So on the check-in, just your general task progress, if there's anything overdue that you are responsible for that you can get done, and then specifically your balance of classes and sub-team work. I can get started, but for me, the main task I've been working on is trying to find an optimal fin shape that will also work with our flutter calculations and now our divergence velocity calculations. The thing that's overdue, I think, right now is obviously our fin design. We have pushed back for a couple of weeks now. So hopefully we can get that done by Sunday night. But also just updating the nose cone documentation from the updated nose cone sims or nose cone drag analyses we did. I guess that's it. And then the balance of classes. Classes are starting to pick up now, especially coming into next week with assignments and then midterm starting. So it's going to be tough, but I have the full confidence that we'll be able to get it done, and we should be able to find a good compromise with deadlines and everything. Yeah, I'll hand it over to you guys.
Yeah, I guess I'll just start it off. Pretty much since the license for FEMAP ran out yesterday and we couldn't thus far get it renewed, I guess until we wait for that, we decided yesterday that we'll just use SolidWorks simulation. And of course, again, this morning, Robbie, you said that. So it looks like that'll be what we do going forward. And since we both can't be at the lab tomorrow, we did plan to meet Friday morning to hopefully get that wrapped up. And that's pretty much it for that.
Thank you, Omar. Sounds like a good plan, and not too worried about the Boattail FEA, especially for switching over to SolidWorks. Should be relatively simple. All right. If no one else wants to share when you're on, unless
I guess I can just say ditto.
Yeah, cool. It sounds like you guys are on the same page, so no worries. The COVID reminders, so same as last week, reminder that you do need a negative test in the past 14 days to get into the lab. Keeping your mask on while in the lab is so important, and then just remembering to sign in and out. It seems like you guys have been doing a good job with that, so keep it up. And then just adding on that, I will send you guys reminder messages to get tested when your 14-day period is up. So if at any time actually you want to request when your next due date, I guess, or when your 14-day period is up, then just shoot me a DM and I'll be happy to provide information. So our task agreement updates, kind of looking the same, but some adjusted dates, and just wanted to highlight a few things that we're going to be focusing on. So Will, if you're watching the recording, if you could please update the documentation of the nose cone decision due to the changes from swapping between the 4 and 6-inch airframe, and then just maybe linking the drag analyses that we did to the folders in the drive. Not looking for too much, just to kind of summarize what happened between the decision of Von Karman versus the OGAV. And then, as I mentioned in the agenda, the fin shape decision, hopefully finished by next Sunday. I'm pretty confident that the Concorde fins are going to be the way to go. I think some things we can look at are 3 versus 4 fins, and I know for 3 fins, Will had proposed probably some pretty big, or the semi-span of the fins were much larger with 3 versus 4. And in the lab yesterday, Amy and I were looking at a 4-fin Concorde design with shortening the semi-span to kind of readjust the center of pressure and therefore stability. And I also took a good look at FinSim, which I guess we'll talk about. But main things wanted to highlight is that documentation due next Monday. If we can each get our own sections of what we've been working on updated, will make the February progress report a lot easier. This Friday for the boat tail FEA, at least with SolidWorks, that'll be good. I think, I don't know if it'll be worth it to come back to FEMA if and when we do get the licenses to maybe do something more detailed. But I think for now, just justifying the launch and maybe the landing load should be good. I also, heads up for the scale model of Zenith for the wind tunnel, I also sent an email to Dr. Florian, the new fluids professor, and hopefully he can get back to us. I think UAV was also looking to do something with the wind tunnel, so it'll be cool to collaborate with them and learn more about flow and drag. So the fin shape decision, as I mentioned, the decision or recommendation by next Sunday, that is the goal. And I know we've been pushing it back a lot. So that Sunday, I think whatever we have will be kind of our formal decision. And from there, I think I'll work with Gustavo, Irvin, and the other leads to try and see how that, I guess, works with the rest of the design. And if we need to make further changes from there, I'll come back to you. And the FinSim program made me aware of something called divergence velocity. So flutter velocity, we hopefully all know about, and what happens when your fins start to flutter and how that affects flight. But there's also a thing called divergence velocity. And I took this quote from the FinSim website. If you actually go to their website, you just start scrolling, it'll tell you everything. It's kind of like how OpenRocket's documentation is, tell you everything about what the program does and how it calculates everything they offer. But divergence velocity, by their definition, is fin or wing divergence is an example of a steady state aeroelastic instability. If a wing in steady flight is accidentally deformed, an aerodynamic moment will be generally induced, which tends to then twist the fin or the wing. It's resisted by the restoring elastic moment, which is along the elastic axis, which is a lot of new verbiage for me, but if you can see my mouse, you'll see the elastic axis is, I believe, just what or where the fin is attached to the body. And then it says above a critical speed, as with flutter, an accidental deformation of the fin or wing will lead to a large angle of twist or torsion. And I saw somewhere this house, as I was trying to figure out what this was, that it does have the possibility to also just completely twist and rip your fins off. So definitely a big concern. But I think with using FinSim, we should be able to account for it and then explain why, I guess, our fin shape and our number of fins has been designed for that. So as you guys know, also, Mike did leave the team, unfortunately. So that leaves Amy and Will as the main responsibilities for the FinShape decision, and I will closely help you guys as well. And I think this week, unlike past weeks, it'll be important to keep in touch with Gustavo throughout the process of what we're doing. Don't want us to kind of solely come up with our own decision. I think due to the new nature and I think weight of the decision that's with analysis, it'll be important to bring in the lead and the chief engineer. Try and keep everything in shape. But tomorrow during lab, I'll continue to work with FinSim, trying to see if it allows for, I guess, like a freeform set rather than trapezoidal. I know there's a bunch of different types of analyses that it offers and different calculation methods. So continuing to look at that, and then also seeing what the effects are with OpenRocket and its stability and apogee. Just a quick word on the Boattail FEA. As I mentioned in the Discord and to Omar and Arturo, transition to SolidWorks for the time being, and that should make it relatively simple, just adding a load to the bottom ring. But I did want to ask if you guys had thought about whether it's worth looking at the landing force, and if there's a way you want to model that. I guess it is more of like a dynamic analysis rather than just the simplicity of adding a load to simulate the launch force. So just want to see what y'all's thoughts are.
Yeah, I think the biggest, or one of the biggest reasons that we would do simulate the landing force would be to see whether, if we were to like bolt this together, if the bolts would shear. I think that's one of the biggest things that we'd look at. But for us to, I guess, kind of really look at that, we'd have to know, like, I guess, how many bolts and what type of screws or bolts do we want to use. But I mean, another thing is, I guess we could just look at maybe generally how it could deform. But again, I guess that would kind of, yeah, that's pretty much it. Just like a stress
If you want
analysis.
to wait a little bit longer, I already asked Structures to work on the bolt thing for you to see kind of what forces they're expecting and all that stuff. But other than that, you can assume that the weight of the payload and the motor casing and all that stuff will, okay, scratch the motor casing, but the weight of everything that is attached to the lower airframe is going to be weighted onto the lower airframe, and the lower airframe bottom edge is what's going to be pushing against the top edge of the lip on the boat tail. So I would assume that the majority of the force would be transmitted into that lip. The bolts are kind of just there to support if necessary, but I do think it's worth looking into, like you said, if it were to slip or something, what would it take to shear those pins or those screws?
Yeah, that makes sense. Yeah, applying the load on that lip would probably be make the most sense. Besides that shear force for the bolts.
All right. I did want to say one thing. I was telling Omar about it. Was it on Monday? And that's that the one thing that I did notice with the CAD model that you guys or Gus sent was that I think if you can meet like anytime after the meeting, I'll show what I mean. But one of the geometries, like just from like working with FEMAP, like I know it's going to cause issues, and it's not a problem with the part itself. It's just a problem with the way it was CAD'd.
Yeah, I actually don't have SolidWorks or anything like the CAD on my Mac, so I've been using this app that is that runs with Siemens software, so I can export natively into XT or like Parasolid. I don't know how it converts between the two of like, or I know there's guidelines on AutoCAD things, so you can have like design intent and all that stuff. But I can try to find the spot in like a lab or something and try to use somebody else's SolidWorks to come up
Okay,
with a
all right.
geometry.
Yeah, I'll just like send you a screenshot and like a brief explanation. It's not very complicated, but I just know it'll cause complications if we try to run FEA.
Cool deal.
But all right, cool.
Great. Just one other point on this. Once you guys complete the SolidWorks analysis, I would like you guys to start to look at other areas of Zenith that could use justification through FEA specifically. And then something I just thought of that would be really interesting to add is when we've been talking to Andrew and Bonnie in the past about just tips with FEA, a lot of the simulations, I guess, we'd like to run just for our technical report and justification, he has said is definitely possible to easily simplify into hand calculations. So maybe that's a route you guys want to look at doing for some other areas of Zenith. And if so, I think that'd be a really cool opportunity to diversify our justification methods and not only just solely rely on or just throw it into or like cat it up, throw it into FEA, see what it says. I think it'll show much more well-rounded understanding of the problems that we're facing, how we tackle those problems, and how we know they're going to work. So moving on to documentation, as I do want to get these different sections ironed out before we start our work on the progress report. Just another reminder, Will, to finish up the nose cone stuff. The fin shape decision, Amy and Will, as you're working on it, that would be beneficial. I don't think we need to get too formal with each of these reports. It should be relatively simple, maybe just an introduction, the type of analysis, what you did, problems you ran into, what you learned, and then a conclusion should be sufficient. Then on the Oberon MMM and Boattail FEA, I don't know if you guys have, I guess, Arturo, you mentioned you were talking about kind of a lessons learned document, and then also including the FEA tips for PMAP and stuff that you guys have been developing. That would be helpful. But if I don't know if you guys have specific documentation for kind of each of the Oberon MMM, and then I'm guessing you haven't done anything for the Boattail as of yet. But if we could get, I guess, 2 separate reports on each, and then kind of group them into with what you guys have been developing, that would be super helpful. The Zenith CAD. Oh yeah, Arturo, you can.
Oh yeah, no, I was going to mention that I did say last week that is the what's called documentation for the Oberon MMM was something that I wanted to work on as soon as we got the Boattail done. That's all.
Yeah, perfect. That sounds good. Just keep me in the loop, and I think I will. I know we had a format, or I made a template for analysis reports early on last semester, but I think that's asking a little too much at this point in the year. So maybe I'll go through and simplify that, and then you guys should be able to follow it pretty easily. And it shouldn't take you too long. And then the Zenith CAD, was Nikolai and Christian talking about what you did post PDR with the CAD and the decisions that we made in talking to other sub teams. That shouldn't be too bad. I will personally take care of the diameter. So talking about why we made the switch from 6 to 4 back to 6. We're talking more about the Boattail and why we decided to make the changes that are reflected in all of our analyses. And if any of you need help with your documentation, just let me know and I will try to help out the best I can. But I'm pretty confident we can get this all done by February 7th, which will then give us a week to then assemble everything nicely in the February progress report and hopefully succinctly describe what the team has been through in the post PDR time that we've been together. That was it for me. A quick meeting, but if you have any questions, that was the time.
Wait, progress report is due on the 14th, right?
Yes, February progress report due February 14th. Each little sections of documentation I would like to be done by February 7th. And throwing it into the progress report shouldn't be too bad. All right, if there's no other questions, then I will stop the recording. Thank you guys for coming out.